Hi, everybody. So the web is getting faster. And according to HTTP Archive, more sites than ever before are passing the Core Web Vitals assessment, which looks at 3 different aspects of page performance: loading speed, interaction responsiveness, and layout stability. And coincidentally, just this week, the Chrome team published a retrospective blog post on the Web Vitals program. And in it, they found that Chrome users saved about 10,000 years of time spent waiting for pages to load thanks to the Core Web Vitals program. So with 2024 approaching, I wanted to ask, what's it going to take to carry this momentum forward and continue making the web even faster? But if we're going to talk about making the web faster, we're going to need to bring more developers and site owners and business leaders into the fold. They need to buy into the idea that web performance is something worth caring about. So let's talk about the why of web performance. Just last week, I was at the Performance.now conference in Amsterdam, and the co-chair and presenter at the conference, Tammy Everts, I think perfectly captured the answer to this question in one slide. In 2016, Tammy published a book called Time is Money: The Business Value of Web Performance. And in it, she draws from decades of experience and volumes of case studies and neuroscience research to conclude that all of these business metrics that you see here can be positively influenced by improving a site's web performance. To give you an example of one case study, an e-commerce site improved their loading performance by 25%, and they saw a 4% decrease in their bounce rate and a 6% increase in their conversion rate. So time literally is money here. So we can say that a happy user will make you more money. And when you think about the traditional marketing conversion funnel, where fewer and fewer users make it to the end, you can look at web performance as a way of greasing that funnel and providing users with a more frictionless experience. So hopefully now that we're all aligned on why web performance matters, let's look at where we are today. I mentioned that the web has never been faster. 42.5% of sites are passing the Core Web Vitals assessment. That's an increase of 2.4 percentage points, or 6% year to date. And this represents an incredible amount of work from the entire web ecosystem. But this is one of those situations that you can look at as kind of a glass half full or glass half empty thing. On one hand, we have the positive story. Half the web is fast. But also you could say a little bit more than half is not fast. But I think that we can have it both ways. It's amazing that we've seen so much progress this year, and at the same time, we can push ourselves to continue this momentum into 2024. So will we be able to keep up the current pace and improve web performance by another 6% of websites next year? I think so. I hope so. But everything is about to change with a new metric to measure interaction responsiveness. And that's interaction to next paint, or INP. Earlier this year at Google I/O, Google announced that INP will replace first input delay as the responsiveness metric starting in March next year. Now, I think this is a very good change. INP does a much better job of representing real user experience issues on the page with responsiveness. But as a consequence of that, fewer sites will have good INP compared to FID, especially on mobile devices. So according to HTTP Archive, if INP were to be included in the Core Web Vitals assessment, the pass rate would only be 36.5%, a drop of 6 percentage points, or 14.2%. Now, this might seem like it's a step backwards, but how the web is actually experienced by the real users is not changing, only our ability to measure it. In this case, a drop in the pass rates does not actually mean that the web is getting slower. So I'm optimistic that we'll see continued improvements in performance. We'll just need to kind of recalibrate our expectations to the new baseline whenever INP takes effect in March. First input delay happens to be the oldest metric in the Core Web Vitals program. It was first introduced in 2018. But only 5.8% of websites have any FID issues at all on either desktop or mobile. So I think it's fair to say that we've gotten a bit complacent. We haven't had to worry too much about interaction responsiveness. INP challenges that complacency. We're going to have to flex some of the web performance muscles we maybe have not used in a while, if at all. We're going to have to learn some new tools. And we're going to have to get very comfortable with something like this. This is what a long task looks like in the performance panel of Chrome Developer Tools. The red striping at the top shows you the amount of time spent above 50 milliseconds doing work, which is what makes it a long task. If there's any user interaction that happens in the middle of this long task, it's effectively blocked until the task can complete. And both the user and the INP metric will perceive this to be a slow interaction. The solution to this will require a new technique that you might not have done before, which is to break up long tasks. Effectively, you're doing the same amount of work, but you're just inserting yield points in the middle at strategic times so that the page can respond to any interactions that might happen in between. Chrome has a couple of APIs that they're experimenting with in Origin Trial to help address some of these problematic long tasks. And the first one is scheduler.yield. This API gives developers better control over breaking up long tasks so that work can happen continuously after you yield back to the main thread, and you won't get another task cutting in line. Of course, knowing which long tasks need to be optimized is its own science. And for that, we also have the Long Animation Frames API. This API reports on the long rendering updates at a frame level, because a frame can consist of multiple tasks, which may or may not be long. And cumulatively, these long tasks, or tasks in general, will still block user interactions. Also, crucially, the Long Animation Frames API includes improved attribution. So for example, you can see who created the task right down to the character position in the source code. So now you can point the finger at any third parties or even the developer sitting next to you for creating these long tasks. And so in your analytics, the same way that you would monitor your INP performance, you could also monitor your attribution info to know why the INP was slow. You can use a data-driven approach to understand what the common performance problems are, as opposed to optimizing by trial and error. And I know that optimizing INP might feel a bit like we're playing catch-up to get back to where we were in a world with FID, but the web will actually be getting faster in the process. I mentioned that the Core Web Vitals assessment looks at 3 different metrics. For it to pass, all 3 need to be good. And so you might think that with responsiveness and INP changing soon, that is the new bottleneck. But that's actually not the case. Loading performance with the largest contentful paint metric, or LCP, is actually the weakest link in the assessment. Only about 54% of sites pass the LCP check, compared to 64% for INP and 76% for the layout stability metric, cumulative layout shift, or CLS. Now, historically, when we've talked about web performance, we're usually talking about loading performance. And so there's a wealth of institutional knowledge built up around traditional techniques like back-end optimization or image optimization. But the web is evolving. The web is more complex today than it was 5, 10, 15 years ago. We have many more third-party dependencies, much richer media, and more sophisticated rendering techniques on the client itself. So I'd argue modern problems require modern solutions. Last year, my colleague Philip Walton introduced LCP breakdown metrics to see where the time is actually being spent waiting for the image to load. The first phase is the time to start receiving the content onto the client. This is known as the time to first byte, or TTFB. The second phase is the time to start loading the LCP image itself. This is the resource load delay. And then we have to wait for that image to finish loading. That's the resource load time or load duration. And finally, we have to wait for that image to be displayed onto the screen. That's the element render delay. Now, conventional wisdom says that if you want an image to appear faster, you should optimize it. You should use things like more efficient image formats. You should cache it for longer. You should make it a smaller size. But in terms of these LCP diagnostics, that only affects the third one, resource load time. What about the rest? Also last week at the Performance.Now conference, Estela Franco presented a talk titled Challenging Assumptions About LCP. In it, we had actually collaborated to present some data from Chrome to show where real users are spending their time on LCP. I'll give you a clearer look at that here in milliseconds. What's perhaps most surprising about this data is that resource load time, or load duration here, is actually the fastest diagnostic metric. The slowest part is the resource load delay. This tells us that the biggest opportunity to speed up LCP images is actually to start loading them sooner. In other words, the problem is less about how long the image takes to load, but it's more about making it load sooner. Now, you might be thinking, wait, didn't browsers solve for this already? There's something called a preload scanner. And yes, that's true. But I think, if you ask me, the problem is that developers are not making their LCP images discoverable. According to HTTP Archive, 36% of sites that have an image-based LCP do not make it statically discoverable in the HTML. One of the issues, if not the biggest, has to do with lazy loading. You can lazy load with both a native-based approach, that's loading equals lazy, or a custom JavaScript-based approach that sets the image source dynamically. 16.8% of websites with image-based LCP lazy load them. I just want to be very clear, lazy loading is good for web performance, but only when you apply it to the non-critical resources. The LCP image is, by definition, a critical resource, so it should never be lazy loaded. Now, there's a very different problem with very similar side effects, and that's client-side rendering. If the only markup that you're sending to the client is an empty div, and then you use JavaScript to populate that div with more content later on, the browser has no way of knowing what that LCP image is going to be. So my hot take, I don't know if it's controversial, move to a more server-side rendering model, at least for the initial load. And the last major discoverability issue I wanted to talk about is LCP images in CSS. For example, the background image style. The preload scanner will only look through HTML for images that need to be loaded as quickly as possible. It will not look in your CSS. And so you're not going to get the benefit of loading that image as quickly as it could. The solution here is actually really, really simple, and you're all already doing it. It's just the simple image tag. Move it out of the CSS and into the HTML. So far, these three LCP recommendations have effectively been rolling back some of the complexity we've added into our applications. But there are also some relatively new additive techniques that we can use to improve performance and maybe even avoid some of these delays entirely. One of them is the fetch priority equals high attribute, which you can hint to the browser that your LCP image should be loaded as urgently as possible. And for such a small change, it's just one attribute, it can actually give you a major performance boost. And when I looked at adoption of this API last year, it was at something like 0.03% of websites with an image-based LCP are using this attribute on it. And today, it's at more like 9.3% of websites. So a lot of people are picking up on this technique, including WordPress, which just released it in version 6.3 a couple of months ago. There are also a couple of techniques to get instant navigations. One of them is the back-forward cache, or BF cache. So there was supposed to, oh, there it is. OK, we do have the video. So here we're starting on TechCrunch. We're navigating to the BBC website. Sorry, New York Times. This is not my video. And then we go back to TechCrunch and forward again to BBC. On the left, the device has BF cache enabled. And you can see on the back and forward navigations, it appears instantly. So because the page is already completely rendered, the LCP image has already loaded, the JavaScript to render that image has already run, it's great for not only loading speed, but also layout stability and interaction responsiveness. We also have the speculation rules API, which is also an experimental API in Origin Trial. This is a hint to the browser that the subsequent page where we think a user is going to navigate should be pre-rendered. So when they do click the link, it appears instantly. Unlike the BF cache optimization, where the user will have already had to visit that page, you can use this API to say, a page that the user has never been to before should be pre-rendered in cache. Both APIs have the same net effect on the user experience, which is an instant navigation. So my hope is that all of you as developers and business leads, site owners, become more aware of these challenges and opportunities to improve web performance, and we'll see continued growth on pace with 2023. But the first hurdle is even to know that your site has a performance problem. And in my opinion, the easiest way to do that is to use the Page Speed Insights tool, pagespeed.web.dev. Plug in your URL, and it will use public data from the Chrome User Experience Report to tell you if you pass the assessment. But even if you do pass the assessment, pay very close attention to your INP performance, because this will become the new standard way of measuring interaction responsiveness in March. You could also use the Core Web Vitals report from Search Console to monitor your site's performance. But even better is to measure it yourself using real user monitoring, because not only can you measure individual pages and individual user experiences, but you also get the benefit of this attribution info, so you can see why your site might be slow. And of course, to be able to act on what you find, you need to have organizational buy-in on why performance is something worth caring about in the first place. And while INP is the new and shiny metric, we can't forget about the largest contentful paint metric and how it's still the weakest link in the Core Web Vitals assessment. We need to focus on optimization techniques beyond image optimization, like discoverability and prioritization. And whenever possible, we need to aim for instant navigations. So the web has gotten 6% faster this year, and that's definitely worth celebrating. But at the same time, most sites are still not fast, yet. If we're going to maintain this pace of 6% growth year over year, then by 2026, we will have reached the point of more than half of websites passing the assessment. And I think that's a goal worth aiming for. So here's my challenge. Let's continue to push our websites, our CMSs, our JavaScript frameworks, and our third-party dependencies to become even faster. And let's continue to be advocates for a faster, if not instant web. So here's to the next 6% in 2024. Thank you.